Hi guys, welcome back to Toon Blend 3D. In this video, I will show you how to create a Low Poly Chibi Knight. First, I create the character reference in Krita using front, side, and back views. You can get this reference on this channel Pinterest account, and you can find the link in the channel description. Alright, let's start by adding the three references into Blender. First, make sure you are in front view. Use the backtick key to set the view. Then press Shift plus A, go to Image, and choose Reference. Select the front view character, reference image, rename it to front to match the character view. Next, go to Object Data Properties, set side to front, and set depth to back. With this setting, the reference image will only be visible from the front. Now add the character reference for the back view. Rename this image to back. Then in Object Data Properties, set side to back and depth to back. Next, change the view to right. This depends on whether the character's side view is facing, is right or left. Then, add the side view reference. Set depth to back and set side to both. This allows the reference to be visible from both the left and right sides. Then don't forget to rename the image to side. Check again to make sure each reference matches the correct view direction. After that, select all reference images, press G and then Z to adjust their position so the character feet are aligned above the coordinate grid line. Next, rename the collection to Ref. Then create a new collection for the character mesh. Now we are ready to continue to the modeling process. We start the modeling process from the top by creating the helmet. Press Shift plus A, then add a cube. Switch to Edit mode. Move it upward by pressing G and Z to place the helmet in the correct position. Then, click the X-ray icon to see the reference image behind the cube. After that, press S to scale the cube. Continue to the Modifier Properties tab, add a modifier, then choose Generate and select Subdivision Surface. Press Ctrl plus R to add an edge loop, dividing the cube into two parts. Add another edge loop on the opposite side. Press the slash key to focus on the current object. Change the selection mode to Face Select. Then, select the top face with holding Shift. After that, right-click, choose Loop Tools, and select Circle. Make sure the Loop Tools add-on is already installed from Edit Preferences under Get Extensions. Next, repeat the same process on the bottom face. Finally, press X and choose Face to delete it. Switch to Right View. Enable X-ray mode or press Alt plus Z. Change the selection mode to Vertex Select. Adjust the scale again to better match the reference shape. Switch to Front View. Pull the middle vertices slightly upward to create a rounded shape on the top. Select the left side of the mesh and delete it. Add a mirror modifier from the Generate menu. Move the mirror modifier above the Subdivision Surface modifier. Enable clipping so the center vertices stay connected. Continue shaping the helmet by moving vertices. Then add edge loops if the shape feels too rough or lacks detail. Then, do not forget to check and adjust the shape from the side view as well. Next, select the bottom edge loop of the mesh while holding Alt. After that, press E to extrude and then press S to adjust the scale. Select the previous edge loop near the edge. Press Shift plus E to control the edge sharpness when using Subdivision Surface. You can also adjust this value from the Item tab using Mean Crease. For the inner circular area, use Loop Tool Circle again. Move it slightly upward to give more depth. Keep refining the helmet shape until it looks right. Press the slash key to focus on the current object. Enable the on-cage icon on the Subdivision Surface modifier so you can edit the final shape directly. Once you are satisfied, switch to Object mode. Apply all modifiers, starting with the Mirror modifier and then the Subdivision Surface modifier. After that, go back to Edit mode. Delete the left side vertices again. Add a new Mirror modifier. Now continue creating the additional helmet details. Switch to Right View. Start with the ear circle on the helmet. Select for faces. Press I2 and Set, and create a new face inside. Enable X-ray mode again if needed. Use Loop Tool Circle to make it round. Then press R to rotate the vertices. Switch to Front View. Press E to extrude and adjust the thickness. Use Loop Tools Flatten so the face becomes flat. Adjust the scale and position if needed. Move the surrounding vertices to form a clean circular shape, which helps improve the topology. Next, create the horn on the helmet. The process is similar to before, but this time use only one face. Then continue with adding edge loops using Ctrl+R. Make sure the center vertices are connected properly. Adjust the shape, position, and sharpness of the horn. Move to the top area of the helmet. Create another raised detail, keeping this one in a square shape. Press I to inset the face. Delete the middle face area. Select the remaining face and move it inward. Adjust the scale and position. Switch to right view. Press E to extrude upward. Use Loop Tool's Flatten to make the face flat. Next, continue with selecting the sharp edges on each additional part. Then right-click and choose Mark Sharp. This will be useful later when using Shade Smooth. Adjust the scale and position again if necessary. Use the slash key to focus on the helmet object. Then, check the mesh again to see if there is anything that still needs to be fixed. Switch to Object Mode, then rename the mesh to Helmet. Go to Viewport Overlays, enable Wireframe, and adjust the opacity. With this, we can see the wireframe of a mesh object even while in Object Mode. Here, you can also adjust the viewport shading to better inspect the model. Next, we create the visor by pressing Shift+A, then go to Mesh and choose Plane. Press Tab to enter Edit Mode, then press R to rotate. Press X to set the rotation axis, and type 90 for the rotation angle. After that, press G+Z to move it upward, then press S to scale. Then press G+X to move it sideways. Add a mirror modifier and make sure the mesh ends are merged together. Position the plane in front of the helmet and adjust its scale. Continue with adding Ctrl+R to insert an edge loop in the middle of the plane. Then move it forward to create a pointed visor shape. Switch to Top View. Add another edge loop and move it forward so it does not get covered by the helmet. Then press A to select all faces and press E to extrude forward. Continue by deleting the back face of the visor. Then tidy up the vertices so the visor and the helmet do not intersect with each other. Move the mouse over the helmet mesh, then use Alt+Q to switch between meshes directly without going to Object Mode. After that, add Mark Sharp and adjust the vertices so the shape looks better. Press Tab to return to Object Mode, then right-click and choose Shade Smooth. Finally, turn off the wireframe option so you can clearly see the effect of Mark Sharp on the mesh. Next, we create an accessory on the back of the helmet, which is a big chain. Press Shift+A, choose Torus, then switch to Top View and set the Torus parameters with Major at 12 and Minor at 8. As a quick tip, if you add a mesh and accidentally click the mouse so the parameters disappear before you adjust them, you can press F9 to bring back the last parameters as long as no other parameters have been opened. Change to Front View, go to Edit Mode, then press RX and type 90 to rotate the torus. After that, adjust the scale and position to match the reference. Select the edge loops in the center, both inner and outer. Then press X and select Dissolve Edges to remove the edges from the mesh. Next, select the sides of the torus and delete them. Then add the mirror modifier. Press Shift and right-click on the center area of the helmet to move the 3D cursor there. Still in Edit Mode, for the next part, add a plane by pressing Shift+A, then adjust its position and scale. Move the plane above the torus. Change the selection mode to Edge Select, then then select the top and bottom edges. Switch to right view. Then extrude it sideways toward the helmet mesh. Extrude again, then press S and Z to adjust the length. Select the top and bottom center vertices, then scale them by pressing S. Continue with adding a new edge loop in the middle by pressing Ctrl plus R, then move it forward so it sticks out. Change the selection mode to Face Select. Press L to select all faces of the hook part. Extrude them by pressing Alt plus E and choose Extrude Faces along normals. Then adjust the position so it looks properly attached to the helmet. We can hide the reference images so we can focus more on the 3D mesh. Apply Mark Sharp, then switch to Object Mode and use Shade Smooth. Go to Viewport Overlays and disable Wireframe to clearly see the Shade Smooth result. After that, go back to Viewport Overlays and enable Face Orientation. If you see red areas, it means some faces have flipped normals. To fix this, select the red object and go to Edit Mode. Press A to select all vertices. Then press Shift plus N to recalculate normals. This step is important for texturing later because faces marked in red will not display textures correctly. After everything is fixed, disable Face Orientation again and rename the mesh to Big Chain and do the same for the visor. Next, we will create the head. Before that, press Shift plus S, then choose Cursor to World Origin to reset the 3D cursor position. Then add a cube, similar to the helmet. Go to Edit Mode and add a Subdivision Surface modifier. After that, delete the top face and adjust the scale and position. Switch to right view, then rotate the object slightly. After that, go to Object Mode and apply the Subdivision Surface modifier. Return to Edit Mode. Delete some faces, then add a Mirror modifier. Make sure to enable clipping on each Mirror modifier. We can delete the edge just below the top edge of the mesh to reduce the vertex count. Then select the top edge and press SZ0 to make the edge flat. Next, check the mesh again to see if anything needs fixing. Enable Statistics in Viewport Overlays to check the vertex or triangle count of the mesh. This step is important when creating and managing low poly models. After that, rename the object to Head. Then return to Object Mode, right-click, and enable Shade Smooth. Finally, disable Show Overlays to preview the object clearly without reference images or other distractions. Next, we will create the character's body. Here we will use a cylinder, then set the vertices to 8 and set the cap fill type to nothing. Go to Edit Mode, then adjust the scale and position. Delete the left side and add a Mirror modifier. Start by shaping the front and side, first forming the chest. Then extrude the lower part and adjust it for the stomach. And add an edge loop in the middle. Hold Alt and select the bottom edge loop. Then press E to extrude and press S to scale it outward. Extrude again for the belt. And finish by extruding and scaling inward so the belt stands out. Next, extrude the top part to form the neck and adjust its shape from the front and side views the same way as the belt. You can hide other meshes to stay focused on the body. For the neck, make it circular using loop tools. Then use Shift plus R to repeat the previous command. Next, we will create the character's arm. Switch to Face Select mode. Go to Right View, select the face where the arm will be, and delete it. Then switch back to Edge Select mode. Then hold Shift and right-click on the center of the arm area to move the 3D cursor. Still in Edit mode, add a mesh circle, set the vertices to 6, press R to rotate, press Y to lock the axis, and type 90 so the circle faces sideways like an arm, then adjust its position. Switch to Vertex Select mode. Disable clipping temporarily to move the circle, and enable it again once finished. Go back to Right View, then adjust the scale and rotate the circle to 90 degrees, so the circle vertices face the arm opening and make the bridging process easier. Then switch to Front View and adjust the position. After that, select the arm area on the body and the circle. Then right-click, choose Loop Tools, and select Bridge, so the vertices connect automatically. Next, extrude and rotate the mesh so the circle aligns straight with the arm, and add edge loops at the elbow and the shoulder to define the arm structure. Then extrude the end of the arm and shape the wrist similar to the belt, or keep it straight if the character does not use metal wrists. Continue extruding to create the hand and fingers. Since this is a low poly model, we will use a 3-finger hand, where the thumb and index finger are separated and the remaining fingers are combined. First, extrude for the base of the hand, then extrude again for the thumb area, and pull the lower part slightly inward to indicate the finger separation. Next, extrude for the other fingers, scale them so the tips become smaller, and pay attention to the top shape of the fingers. Press S and use the middle mouse button to control the scaling direction. Then select the edge at the fingertip and press F to create a new face. Now we will shape the fingers by separating them using a cut. Start from the top part, then press K to use the knife tool. Continue the cut down to the bottom of the hand, and when finished, press Enter. Next, select the edge at the fingertip area and press V to split the vertices. Then switch to Top View and press G twice to slide the edge vertices along the existing shape. And make sure you select the correct edges. Fill the empty area by pressing F to create a new face. Then add edge loops in the middle of the finger and move them slightly upward. Press Ctrl+B on those edge loops to bevel them, using the scroll wheel to add or reduce edge loops. Select the lower middle edge of the 3 edge loops on the index finger and press Ctrl+B again to bevel the bending area. Next, continue working on the bend of the adjacent finger. Press K to add additional edge vertices for the finger bend. Since the index finger blocks the view, hide it temporarily. Start by selecting the tip of the index finger. Then press Ctrl and plus to gradually expand the selection to the surrounding vertices. Repeat this until the entire index finger is selected. Then press H to hide the vertices. After that, continue adding edges using the knife tool. Then select the edge in the middle of the bend and delete it. When finished, press Alt+H to unhide the previously hidden vertices. Finally, adjust the top of the fingers so they slightly tilt toward the pinky side. Next, create the thumb by selecting the face, extruding it, and adjusting its position. Then add edge loops at the thumb tip and move them slightly backward. Next, continue by adding another edge loop in the middle. After that, use Ctrl+B to create the bending area, similar to the index finger. Finally, adjust the scale if needed to refine the shape. Next, we create the foot area. While still in edit mode, add a cylinder and set the vertices to 6. With the cap fill type set to nothing, position it at the leg area. Temporarily disable clipping on the mirror modifier, then rotate it on the Z-axis to 90 degrees. After that, adjust the position and scale to match the reference. Continue by extruding to form the shoe shape based on the reference. Then use Shift+Z to enable wireframe mode. This makes the mesh transparent and clearer to see, compared to using X-ray mode. The most important part here is making sure there is proper topology at the ankle bending area. Using Ctrl+B, similar to what we did on the fingers earlier. After using Ctrl+B, if you check and move the vertices around the ankle, you may notice overlapping or duplicated vertices. To fix this, first press A to select all vertices, then press M and choose by distance, then recheck to make sure there are no doubled vertices left. Next, make the shoe look more solid. First, select the shoe area up to the knee, then extrude it using Alt+E and choose Extrude Faces along normals. Use Ctrl plus Numpad plus to expand the selection area, then adjust the scale from both the side and front views. Continue refining the shape by adjusting the rotation and vertex positions. After that, try connecting both legs. Enable X-ray mode, select part of the edge loop, then extrude and rotate it so it connects properly with the mirrored side. Then select the edge loop on the upper part by left-clicking while holding Alt. Flatten it by pressing SZ0 and adjust it so the center area does not sink inward. Make sure the waist vortices align nicely with the belt vortices on the character. Next, select both edge loops and connect them using Loop Tool's bridge. Then refine the shape so it looks cleaner. You can also add extra edge loops using the knife tool by pressing K. And hide the reference image if needed to focus on refining the mesh shape. At this point, the base body is complete. You can duplicate this base body later to reuse it for different characters. Next, create armor for the neck area. Add an edge loop in the middle of the neck, then move it downward until it aligns with the shoulders. After that, tidy up the lower edge loop vertices so the shape looks smoother and more naturally circular. Then use Extrude Faces along normals and adjust the rotation and position until the armor looks better. Then move on to the shoulder armor. First, slide the edge loop to define the size boundary of the armor. After that, you could separate the armor from the body by selecting the face area. Duplicate it by pressing Shift+D, then press P for separate and choose selection. Next, switch to object mode and select the separated mesh, then return to edit mode. Select all faces, then extrude them using Extrude Faces along normals. This method makes it easier if you want the armor to be removable and reusable. However, in this case I do not use it because it can also increase the vertex count. Continue by extruding faces along normals to shape the armor. Scale the armor length and determine the axis using the middle mouse. If the transformation does not work correctly, change the transform orientation from global to normal. Then try again so the axis follows the mesh direction more accurately. After that, add more layers to the armor by extruding faces along normals again. Then scale it inward and move it upward so the armor looks more voluminous. Then continue adjusting the armor so it looks more appealing and well balanced. Next, add additional topology for elbow bending on the arm area and make sure to merge the vertices afterward. Continue to create the chest armor by adjusting the topology to follow the reference shape. Then extrude it similarly to the shoulder armor. Then continue creating the back armor. For the front part of the belt, add extra edge vertices using the knife tool, then extrude them to form the detail. Then create the cloth extension under the belt. Select the edge loop, duplicate it, and extrude it downward. After that, separate it using V on the edges. Move it using G twice to slide along existing edges. Shape it based on the reference. And merge the duplicated vertices using merge by distance. Finally, review the entire body mesh to see if anything is missing. Switch to object mode and apply shade smooth. At this stage, the body mesh shading may not look correct. Because of that, go back to edit mode and add mark sharp on the sharp edges. We can also add commands to quick favorites. For example, right-click on mark sharp, then choose add to quick favorites. After applying mark sharp, we can immediately see the difference and continue adding mark sharp to the other edges. After adding the mark sharp command to the quick favorites tab, press Q to open quick favorites. This helps speed up our workflow while working in Blender. Finally, continue to add marked seam. Place seams along shape boundaries like armored edges to make texturing easier later. After adding marked seam, switch to face selection mode. Then hover the mouse over a face and press L to check whether it's correct or not. After finishing the marked seam check, rename the mesh to body. Next, unhide the mesh and image reference, then continue creating the plume mesh. There are two ways to make plume here. For the first method, add a plain mesh, then rotate it so it faces forward. Add some edges, delete one side, and add a mirror modifier. Next, pull the edge on the side toward the back. Then extrude the top edge and adjust its position and rotation to curve it backward. For the second method, it's similar to the previous one. Start by using a plain mesh, then adjust the height and width of the plane. Add an edge in the middle, delete one side of the edges, and add a mirror modifier. After that, add edge loops to the plane. Then adjust the scale, and to make the plume curve, we will use rigging and control it in pose mode. In this video, we use the first method. After that, continue by adding mark seam to all character meshes. Then don't forget to name the plume mesh. Once everything is done, go to Object mode, check the entire mesh, and save the project before continuing. Next, we start the UV unwrapping process. First, switch to the UV editing layout. In Object Mode, select all meshes, then go to Edit Mode. Press A to select all vertex and press U to unwrap, then choose Unwrap Angle Based. On the side, you can see the result of the UV unwrap. In the UV editor, enable UV sync selection so we can directly see which UV is selected. Press F on the UV to automatically select each UV island one by one. Next, we start UV mapping, beginning with the head. Select all faces on the head, then press Shift plus H to focus on the selected faces. Here, I will unwrap again using Project from View. This method depends heavily on the view direction, so make sure you are in the correct view. For example, unwrap the front in front view, the back in back view, and the bottom in bottom view. Next, I will use the UV Toolkit add-on to manage the UV mapping, so make sure it is already installed. Then, move the UVs that are not finished yet to the bottom area of the UV map. After that, select all UV islands, then go to the UV menu and choose Average Island Scale. This makes the UV islands match the size of the UVs on the 3D object. Next, we create UV straighten using UV Toolkit by selecting UVs that are suitable to be straightened. With this technique, we can paint textures directly on the 3D model with more detail. However, the downside is that painting textures on the 2D UV map becomes less optimal, so use this method based on your needs. For UVs that are not straightened automatically, even if they are based on a square shape, we can do it manually. Select the UV edges, then straighten them using the Align menu with Vertices mode. After that, arrange the straightened UVs neatly in rows. Here, I want to show how UV unwrapping with Project from View results in UVs that closely match the 3D shape, making it easier for direct 2D texture painting. However, the texture result is not optimal, especially for low poly models with small texture sizes. This method works better when using larger UV space and higher texture resolution, so again, adjust it to your needs. If we check it using a UV checker map, we can see that the texture is distorted. Because of that, I didn't use Project from View for the shoes. Instead, I only used Unwrap Angle Based. Next, continue the UV mapping. With this add-on, we can easily adjust things like making a UV island stand upright based on selected edges using Straighten Island. For finishing, straighten the UV islands using the Align command with Island Mode in UV Toolkit. With this add-on, we can also directly create a UV checker map texture. First, set the size. Here I use 1000 by 1000, then choose the checker type. I use Color Grid, and after that, click Create Checker Material. Now we can see the checker grid texture applied to the 3D character. Switch back to the Edit Mode layout, then press Ctrl plus Backspace to focus on a single layout. This helps us check the UV grid more clearly. The purpose of the UV checker grid is to quickly see how textures will behave on the 3D character. If lines or letters look distorted or bent, the same issue will appear later when painting textures. As you can see on the character's pants, the lines are slightly bent. We can fix this by adjusting the problematic UV areas, repeating Mark Seam, and UV unwrapping only on the necessary parts. Select the faces using L in Face Selection mode, and enable UV Sync selection if you want to see the UV changes directly. You can also manually adjust it directly on the 3D object by moving the vertices. In this case, I'm not fixing it further because this area won't have highly detailed textures. Once the inspection is done, We can remove the checker texture by clicking Remove Checker Material in the Cleanup tab of the UV Toolkit add-on. This feature is very helpful. With that, the UV mapping process is finished. Next, we will start painting. Switch to the texture painting layout first. Here, we will use the Ucupaint add-on, so make sure you have already installed it. You can visit the add-on creators channel, Ucupumar. You can also support it directly by clicking the heart icon. By supporting it, we help the development of this add-on. We should really appreciate it, since this add-on is free, so let's support it. Now, let's start painting. Begin in object mode. Select one mesh object. Here, I select the body. Select Quick Ucupaint Node Setup. Then choose Emission and enable Alpha. Here, you can also rename the material. Before continuing, go to the Render tab, then Color Management. Change View Transform to Standard, and set Look to Medium-High Contrast. Next, press A to select all meshes and making sure the body mesh is selected last. Then press Ctrl+L and choose Link Material. This makes all meshes use the same material. Next, I add a reference color palette. You can also find it on Pinterest account from this channel. Then, rename this reference. Then select the character mesh. Here, I select the body. Switch to Texture Painting mode, go to the Tool tab, then Color Palette. Here, you can name the palette. Next, add colors from the reference palette. Press Shift+X, then move the pointer to the first color in the reference palette. Blender will automatically pick the color under the pointer. Then add the color by clicking the plus icon in the color palette. Or, you can directly press Shift+X and left-click on the color in the reference palette. Then Blender will automatically pick and add the color to the palette. After that, create a new layer. Click the plus icon, choose New Image, then rename it to Base Color. Set the resolution size or customize it based on your needs. Here, I use a 2048 resolution because it's easier to downscale later when baking or exporting the final texture, rather than increasing the resolution, which won't improve the texture quality. Then click OK. You can also enable wireframe to make texturing easier. Next, focus on the body by pressing /key. Then switch to Edit mode. Select the armor on the body using Face Selection mode and press L. Go back to Texture Painting mode and choose the armor color from the color palette. Change the brush type to Fill, then enable the mask icon at the top. This mask ensures that only faces selected in Edit mode can be painted. Left-click in the Texture Paint viewport, and the color will automatically fill the selected faces. Continue applying colors to other faces using the same method. After finishing the fill colors, we will start creating basic patterns using a brush. Here, I use the Paint Hard brush. Change the stroke type from space to line. This makes it easier to draw straight lines. Press F to adjust the brush size. Left-click, then hold Alt to create straight or 45-degree angled lines. Continue shaping the line patterns. To switch between color 1 and color 2, press X in the viewport area. You can also go to Edit mode, select the face area you want to texture, then press Shift+H to focus on the selected faces. After that, return to Texture Painting mode and continue applying the texture. After finishing the texturing, go back to Edit mode and press Alt+H to unhide the faces. Then return to Texture Paint mode. When you feel it's done, rotate the body mesh to check if there are areas that still lack color or patterns, especially on the lower parts like the feet. Then press /key to exit focus mode. Move the mouse pointer to the head mesh and press Alt+Q to switch directly to another object without leaving texture painting mode. Continue applying colors using the fill method, then move on to the plume mesh. Here, We'll paint it directly in the 2D UV texture. If some faces look distorted or the texture does not match the 2D UV texture, check it again using the UV grid checker. Adjust the vertices until the texture looks correct and inspect it from multiple views. Next, continue creating the plume texture. We can also use line stroke on the eraser brush. Then set the alpha value to 0. This makes the plume look like it has many layers, even though it's actually just a flat mesh using texture transparency. After that, continue applying the base color. We move to the upper part of the hand. We try to make the hand look like it has fingers by creating boundary lines to define each finger. Finally, do an overall check. Disable overlays to see the character mesh clearly without wireframe and without needing to turn off wireframe mode itself. Next, we will create a square or diamond gambeson pattern for the pants and the character's arms. Add a new layer and choose Generated Wave, then click OK. After that, add a mask layer and choose New Color Attribute Mask. Change the color from white to black, then click OK. Go to Edit Mode and enable Overlays again. Select the body faces by pressing L in Face Selection mode. Then choose White in the Fill Mask Attribute option. With this, the wave layer will only appear on the areas filled with white. Next, adjust the wave pattern settings. Set band direction to Y, profile to SAW, and adjust the scale as needed. Here, I set it to 12. Then go to Vector, set rotation to 45 degrees, and change the color channel to Dodge. Next, add a color ramp modifier, set the alpha to full, and adjust the color ramp so the wave pattern blends nicely with the base color. After that, duplicate this generated wave layer. Set the rotation to -45 degrees so both patterns form a diamond or gambeson pattern. Then, flip the color ramp. Next, add a new bake layer called Paint Base. Set the resolution, set the margin to extend, and 4 samples, one is optional and enough for this example. And for the bake device, choose whatever you prefer, either CPU or GPU compute. Here, I'm using GPU compute. Then click OK. After that, set the color channel to soft light. And next, add an ambient occlusion bake layer. Set it the same way as the paint base layer, then click OK. Set the color channel to soft light. Then continuing, add a color ramp, and adjust the brightness and contrast so it looks more comfortable to the eye. Then, add a generated edge detect layer. Change the color channel to Dodge, and adjust the radius. Once it looks good, bake the layer the same way as the paint base layer. Next, add a mask layer and choose New Color Attribute Mask. Set the color type to white, then click OK. Go to the plume mesh, switch to Edit mode, select all faces, and fill them with black in the mask attribute. Do the same process for the ambient occlusion and paint base layers. Then, check the entire mesh to see if there are any issues. For example, here we can see a line on top of the helmet even though we never painted it. This happens because of a baked layer result. To find out which layer causes the issue, hide and unhide the layers one by one. Here, we find that the ambient occlusion layer is the cause. To fix it, we first need to understand why the line appears. The line happens because there is another mesh nearby. So when baking the layer, it is affected by the mesh shape, not the painted texture. To fix this, hide the plume mesh in both viewport and render. Then rebake the ambient occlusion layer, making sure another mesh is selected, not the plume mesh. After that, we can see the line is gone. However, there may still be other small lines. If they are minor, we can fix them by blending, using the smudge brush or blur brush if needed. Here, we can also see a small dot in the mesh. This might happen because the fill brush on the base color layer was not evenly applied. Fix this by using a hard paintbrush with the same color as the helmet. Paint over those areas in the base color layer. Next, create a gradient layer using a new image layer. Use the same resolution as the base color layer. Make sure this gradient layer is placed at the top of all current layers. First, change the brush to fill, then switch the color picker from color to gradient. Start with the plume mesh. Left-click to place the first gradient point, then drag the gradient line in the desired direction. The first click represents the first or leftmost color in the gradient, and the end point represents the last color. Make sure you understand how it works, and repeat until it feels right. Use black as the shadow color and white as the lighting color. Then change the color channel to soft light to see the gradient effect directly. After that, move to other meshes using Alt+Q. You can also use masks to apply gradients to specific faces on each mesh. If blocky artifacts appear when applying the gradient, fix them by changing the view direction or zooming in or out. This usually resolves the blocky artifact issue. As for why this happens, I'm not entirely sure either, but this explanation comes from Copilot. Continue this process until you reach the body. Use masks for each different part of the body mesh, such as armor, clothing, and other areas. We create a new image layer for detail painting and we use the soft light channel. Start from the visor. Create a whole pattern using a hard paintbrush with line stroke. Use Shift+Z to enable wireframe preview so we can still see the reference even in texture paint mode. Continue creating patterns based on the reference. If you ask why not do this directly on the base color layer, yes, that is possible, but the black color will become pure black if painted directly on the base color. It can still be adjusted later, so just choose the method that fits your needs. Next, create sharp shapes using the eraser. Use line stroke, aim toward the center from outside the circle, and press Alt to get a 45-degree angle. After that, press X to switch the color to white for highlights. Lower the strength, then follow the edges of the pattern. Use the blur brush to blend the corners where lines meet. Continue adding detail patterns on the helmet. Create a line from the top of the helmet, then add highlights on both sides. Try adding an extra plate pattern. For bolts, change the stroke to drag dot. This makes it easy to create circular shapes and move them around. Then continue with the ear circles. Move to the big chain behind the helmet and apply the same steps as before. After that, move to the shoulder armor on the body. Create the same pattern as on the visor. Continue to the gloves. Make the armor feel more volumetric by adding shadows and highlights. Next, move to the legs. Go to Edit mode, select the leg faces using L in Face Select mode, then press Shift plus H to focus only on those faces. Try creating lines so the armor looks layered. Start drawing from the right view, then switch to the front view. You will notice the line is not straight. Try again from the left view. Temporarily disable Display Viewport Mirror, then continue drawing the line. Check again from the front view. You can see the left side looks straight, but the right side does not. To fix this, select both faces and press Ctrl plus T to triangulate the faces. Remove the previous line and redraw it. Now the line should look better. This step really affects the result. Next, look at the sole of the shoe. It looks too bright even though it is on the bottom. This might come from a baked layer effect. To fix this, find the layer by hiding and unhiding layers, then go to Edit mode and add a black mask to that layer. If you see strange lines like this, try removing them using the blur or smudge brush. After that, go back to Edit mode. Press Alt plus H to unhide all faces and enable Display Viewport Mirror again. Continue to the belt. Let's make the gem look more interesting. First, we set up the masking on the paint base and edge detect layers. Then create a black to white gradient from bottom to top. After that, draw a black line around the gem, followed by a white line around the black one, so the gem looks more volumetric. Move to the next gem and apply the same method. But this time, create the gradient manually, since this is only a texture pattern on flat faces, not an actual gem shape. Continue adding details to the other gems. Next, manually create a gradient effect on the gold stripes on the clothes to make them look more attractive. Lower the brush strength to make it easier to control light and dark reflections. Use blur and smudge brushes to smooth the gradient. Then add black shadow lines along the edges of the gold lines so they pop and feel more volumetric. Continue applying this to the other gold lines. You can also add scratch details on the armor. For example, on the shoulder armor, draw a black line, then add a white line along its edge. Remove the sharp line edges using the blur or smudge effect. Next, we move on to the plume mesh. We could paint the line details manually, but that would be tiring and not very clean. So instead, we'll use a generated wave layer. After that, add a new image mask layer so the effect only applies to the plume. Change the color channel to soft light, then adjust the scale, rotation, and profile to get the look you want. Add a mask to the straight bone area of the plume, then add a color ramp modifier and adjust it so the colors blend better with the surrounding colors. You can also add a generated magic mask layer to give variation to the wave pattern. Adjust the scale and blend of this mask. Then, add shadow using a soft paintbrush on the detail layer. For the straight bone pattern on the plume, you can paint it manually or use another generated wave layer like before. If you want to change the plume color without affecting the base color, create a new layer. Add a new image layer. Use the fill brush, switch the color picker to gradient, and choose the gradient colors you want. Apply the gradient color to the plume. Then change the color channel of the layer to color. Add an image mask so the straight bone area of the plume is not affected. If the generated wave layer still looks too contrasty, lower its value. Then, to easily adjust the gradient color later, add a hue saturation modifier to the layer. Now you can tweak the gradient color just by adjusting the hue parameter. After that, add final shadow and highlight details. You can disable the hue saturation modifier if you no longer need it. The value of this layer is not limited to 1, you can increase it to 2 or even higher, depending on the look you want. Move the detail and gradient layers to the top. Layer order affects the final result, so make sure they are placed correctly. Finally, fine-tune the wave and gradient parameters if the result still feels off. Next, let's clean up and soften any rough areas or dark stains caused by baked layers using the smudge brush. For example, under the pants here you can see a dark line, so we smooth it out using smudge and blur brushes. We can also use the smudge brush to create a painterly effect either on the paint base layer or on the ambient occlusion layer that we baked earlier. If you want to revert the result, you can always rebake the layer, so make sure you save the project regularly. After finishing the texturing, the next step is baking all layers into a single texture. Click the gear icon on the color channel and choose Bake Color Channel. Set the texture resolution. Here we try 512 pixels, set the margin to extend, and click OK. You can see the texture still looks fine, but it becomes blurry when zoomed in. We can go back to Layer mode and then return to Bake mode. Now let's rebake again with a custom resolution of 256 pixels. Here the texture starts to look blurry. Then we rebaked again and changed the interpolation from linear to closest. Now the texture looks sharper, but pixel blocks appear along the pattern edges. Next, enable anti-aliasing samples and set the value to 2. The result looks cleaner and keeps the pattern shape more accurately. Then try changing the interpolation to cubic. The result looks similar to linear, but more blurry and very soft. Next, try closest interpolation again with 512 pixel resolution. However, on the face seam area, it's still visible. We try increasing bake samples to 101,000, but it doesn't really fix it. Instead, we increase the resolution to 1024 pixels and reduce the samples back to 1. And now the texture looks smoother. If we go back to linear interpolation, the pattern lines become smoother. But when we lower the resolution back to 512 pixels, the texture becomes blurry again. Here are some comparisons of different bake parameters we tried. In the end, I choose 1024 resolution with linear interpolation. After that, save the baked texture image and make sure to use PNG format. Next, I'll show you how to edit the baked texture using external painting software. Go to Edit, then Preferences, then in the Application tab under Image Editor, choose the software you want to use. Here, I'm using Krita because it's free and has many useful features. Browse to the folder and select the application file with EXA format. Alternatively, you can right-click the Krita shortcut, open Properties, copy the target location, paste it into Blender, and remove the quotation marks. Then save Preferences or enable Auto-Save Preferences. Go to the Image Editor layout, then Image, and choose Edit Externally. Krita should open automatically and display the texture image you saved. If it doesn't open, try opening Krita manually and click Edit Externally again. Once it's open in Krita, we can start editing the texture, especially on the plume. However, we don't know the UV wireframe boundaries yet, so we need to extract the UV layout. Go back to UV editing, select all meshes in object mode, then go to Edit mode and disable UV sync selection. Then press A to select all faces, then go to the UV tab and choose Export UV Layout. Then give it a name, then make sure the format is PNG and use the same resolution as the baked texture image. You can also adjust the UV fill opacity here. Then go back to Krita and open the UV image. After that, copy it and paste it into the texture file as a new layer. Lower the layer opacity so it doesn't cover the texture too much. Then we add the same color palette as the character, so the plume colors match and feel consistent with the character. Now we're ready to start editing the plume texture. After finishing the plume texturing, save the image. Then go back to the Texture Paint viewport in Blender and press Alt+R to refresh the image texture. Or, you can also go to Image and choose Reload. Make sure the color palette layer is hidden. If you want to go back to a previous texture version, you can rebake the texture again and save it, and do the same process as before. You can also add a subdivision surface modifier to the plume mesh to make it look smoother. However, keep in mind that this will also double the number of vertices on the plume. With this, the character texturing is finished. Next, continue to rigging and animation. First, go to the Layout workspace. Here we'll use Rigify add-on. Press Shift+A and add armature. Then choose Basic Human. Then make sure the 3D cursor is at the world origin. Go to Edit mode, then open Data Properties. In Viewport Display, enable in front so the bones are visible in front of the mesh. Next, scale the armature and press period to set the pivot point to the 3D cursor. Then, press S to scale. Before we start adjusting the bones, enable the mirror option first so the bones stay symmetrical. Press G to adjust the position of the arm and leg bones. Check both front and side views to make sure everything lines up properly. Select the chest bone, press X, and delete it, since we won't be using it. Then select the upper torso bone, press X, and choose Dissolve Bone. Do the same for the head area so the neck only has one bone. After that, fine-tune the armature positions. Next, go to the Sample tab and add finger bones. Move the 3D cursor to the hand bone by pressing Shift+S, then snap the sample finger bone to the 3D cursor. Adjust the finger and press F2 to rename it as index finger, and make sure to adding .+L at the end of the name. Then press Shift+D to duplicate it and adjust it for the middle finger. And duplicate again for the thumb. Select the root of each finger bone and the hand bone, then press Ctrl+P and choose Keep Offset to parent them. After that, move the mouse pointer and press L to select all finger bones. Right-click and choose Symmetrize so they mirror to the other hand automatically. Reset the 3D cursor back to the world origin. Add a basic super copy bone for the big chain. You can also use this bone for the visor if needed. Then parent this bone to the head bone. Next, add a simple tentacle limb to control the plume. Adjust it to follow the curve of the plume and press E to add more bones if needed. Then parent the root of the plume bone to the head bone. Continue with rename the bones for big chain, plume, head, and neck so everything is clear. After that, add basic super copy bones to control the fabric edges of the character. Then select and hide the blocking bones by pressing H. Set snapping to face project and enable affect move, rotate, and scale. Adjust their positions and rename them properly. Press Alt+H to unhide the bones that were hidden before. Then parent all fabric edge bones to the hip bone. Select the bones and use Symmetrize. Then, to be safe, press A to select all bones and run Symmetrize again on the armature. Once everything is set, generate the rig. You can rename the armature before generating if you want. Click Generate Rig, then hide the meta rig. Then select the generated rig, then select all meshes, press Ctrl+P, and choose with automatic weights. Switch the rig to pose mode to check the result. Before fixing weight paint, set up the bone widgets using the Bone Widget add-on. You can get it from Wayne Dixon's channel or directly from the Get Extension menu in Blender. And I'm using the version from Get Extension, then setting the panel category to Item. Next, start adjusting widgets from the hands. For example, change them to cube shapes. Edit the widget. Then click to bone. Then, try Symmetrize Shape. If it fails, go back to the meta rig, symmetrize the bones again, and regenerate the rig. This usually fixes the widget symmetry automatically. After regenerating, the parenting to the characters should still be intact. Then continue adjusting widget shapes to make animation easier. Repeat the same steps if you encounter symmetry issues again. Next, check the rig deformation on the character to see which parts need fixing. Before that, switch back to object mode. First, we start with select the plume mesh. Go to Vertex Groups, find the plume bone group, and lock it. Then continue with delete the other unused vertex groups. For the helmet, keep only the head vertex group and do the same for the visor. For the head mesh, keep the head and neck related vertex groups. Continue with the big chain mesh, then lock the big chain and head vertex groups. Then switch to weight paint mode and adjust the weights so the big chain bone only affects the ring part, not the hook. Change the brush type to gradient to speed up the weight painting process. We can also use masking while weight painting, and directly click the mesh faces or press L to select face areas in weight paint mode. Here, the weight paint on the ring part of the big chain is already correct, so we just need to fix it so the hook mesh is not affected by the big chain bone. Red color means the mesh is strongly influenced by the bone, so we need to remove the weight there. Right-click and set the weight value to 0, then click and drag to apply the gradient weight. If it doesn't work, make sure the vertex group is not locked, so unlock it and try again. Blue color means the mesh is no longer affected by the selected bone. If you accidentally delete an important vertex group, like the head group on the chain hook, don't worry. Copy the vertex group name from another mesh. Then add a new vertex group to the big chain mesh, paste the name, and repaint the weights. Right-click, then set the weight to full, and make sure the hook mesh is filled and turns fully red on the head vertex group. Next, we fix the helmet mesh. There's one vertex that didn't get automatic weight paint before, so we manually paint it by filling full weight on the helmet mesh in the head vertex group. After that, we continue by checking the rig we fixed earlier in pose mode. Then we move on to check the body, especially around the waist and the legs. After checking, we can see that the fabric edge bone is still not optimal, so we fix the weight paint one by one. After that, test the fabric edge rig again. Once it feels correct, we continue fixing the leg part. After that, check the entire rig and try making a pose. Then, if everything feels good, we move on to animation. Next, we'll create a simple idle animation. Then I'll keep this part brief. I use a simple idle pose sketch as reference, which you can find on this channel's Pinterest account. In the animation layout, I'm using the Dope Sheet tab at the top, the nonlinear animation in the middle, and the timeline at the bottom. First, create poses one by one following the reference. Set keyframes for each main pose, with equal spacing. Then, between these poses, add secondary motion for accessories like the plume, big chain, and fabric edges. For some poses, change the keyframe interpolation by pressing T. For example, when the character wakes up in surprise, use back interpolation so the motion has a slight bounce. Then for other poses, use linear interpolation. To use non-linear animation, first create a regular keyframe animation, then click Push Down action. This converts the animation into strips. Then you can also re-edit the keyframes that have already been turned into this strip. You can rename strips, split them by pressing Y, and move them around. Rename tracks to describe the duration or purpose of each strip, which helps with timeline control. To focus on one strip, enable the star icon. Then, if no star is enabled, the top strip will be played. You can lock strips or delete tracks by right-clicking on them and choosing Delete. Then the same workflow can also be applied to camera animation. For rendering, you can make the background transparent by going to Render Properties, Film, and enabling Transparent. Then go to Output Properties, set File Format to FMPEG Video, Encoding to QuickTime, then Video Codec to QuickTime Animation, and Color to RGBA. If you want to render exactly what you see in the viewport, go to View and choose Viewport Render for either image or animation. With that, the Low Poly Chibi Knight project is finished. Thank you so much for watching from the beginning. Then, see you in the next one.